Hi, for those of you who've been watching some of my other videos, I mentioned that we're working on a level 2 certification, and in that video I showed the rocket that we plan to use. What I thought would help answer some further questions is make a video of the actual construction process. So I'm going to start taking a little bit of video as the rocket makes its progress, kind of explain some of the things that we do to construct it. So this is called a HyperLOC 835. It's a cardboard rocket kit. It will have 74 inches total height, weight 60 ounces. It's actually going to weigh more than that when I'm done because I'm going to be adding a lot to it. The diameter is 4 inches. It claims if you build it the way they suggest, it'll get up to 4,300 feet. But we're going to make this a much higher power, stronger rocket. So we'll be able to push this rocket well over 9,000, 10,000 feet. And we will go into engines I, J, well up into K on this rocket. This is a 54 millimeter motor tube. So that's a bigger rocket engine than we've done up to now, so that's why the level 2 requirement. And this also will be our first rocket with dual deployment. So what we have here is the kit. Comes in a box. This is the box it came in. This is actually what the rocket will look like when it's all said and done. The actual components are here on the table. You can see it's all cardboard. So what we're going to do is we're going to do a fiberglass laminate over this. So we're actually going to peel, this is what they call the glassine layer, off the tube, and once it's peeled we're going to roll a 5-ounce web of fiberglass using epoxy, and then after that's done we'll put another layer of 3-ounce on all the tubes. We're also going to do a 5 and 3 over the fins after they're on the rocket, and this is the motor tube. We'll also put it in fiberglass also. So what that will do, it'll add weight to this rocket, but it'll be compensated by the amount of extra thrust we can put into it. Much bigger engines, much more lifting power, and that's how we get up to 9,000 feet. That's how we can break the sound barrier. The rocket would be able to exceed the altitudes and basically work identical to much more expensive kits that come already made in fiberglass. So these are all the pieces, and I'm just going to go through those real quick. Again, it's a 4-inch diameter rocket. This is the booster section. This is where the fins go. So basically the fins, once on, will look something like that. The fins are like a balsa plywood type material, very thin for the kind of altitude and speed we're going at. This wouldn't last very long, so that's why we're going to do what's called a tip-to-tip fiberglass. After the tubes are encased in fiberglass, we'll attach the fins, and then we'll actually do an overlay of fiberglass from tip to tip. In other words, one continuous piece of fiberglass will go from this point to this point, taking the form of the rocket. This is on top of all the epoxy that we've already put on, all the filaments, and so to make it very almost indestructible. So again, this is the booster. This rocket has what they call an extension booster, this piece right here. All this really serves is to give you extra link in the main tube. So you have a spacer, goes in here, and you put these two. These will be permanently glued together. So the booster technically will be this long. If you can back up, you can give me a long shot there, and you can see how. So this will be one booster. Those two pieces will be made together. Once it's fiberglass, we'll do a continuous sheet of fiberglass so that it will be seamless. This all will become one tube when we're done. the main point, this is your payload section with a plastic blow molded nose cone. This is the payload. So basically the way it works is the main chute will go in this section of the rocket. This is the main chute here. We may have to go up to a bigger chute depending on the weight of the rocket. We want to make sure the descent is like under 20 to 15 feet per second, and the simulator will tell us once the rocket is done. We'll be updating the simulator dimensions and weights as we build this, so the simulator is accurate. This section, which is one piece, will have the drogue chute. This is the drogue, just basically a small chute. So the idea in dual deployment is you have an altimeter. Ideally you have two altimeters in case one fails. The altimeter reads the outside pressure. It knows when the rocket has reached its maximum altitude because it'll detect the lowest point in pressure. Then when it starts sensing pressure building again, it knows it reached its apogee. It will actually light a charge of black powder. Basically it's a canister that we put in here. It's hooked up to a battery. Once that shoots off, this piece comes separate from this piece and the drogue chute comes out. Now the chute is very small. Base of the rocket is falling straight down, but the chute basically just slows it down so it's not completely free falling, but still falling pretty fast, and the idea is it's falling straight down. So if it goes 9,000 feet up in the air, it's falling straight down. The altimeter is set that when it gets within 500 feet roughly above the ground, it will hit another charge that will then separate these two pieces, and then what comes out of here is the main chute, and the main chute will pop 500 feet above the ground, and then basically that's enough time to slow the rocket down to roughly about 15 to 20 feet per second, and then all the pieces hit the ground without any damage if it works right. So nose cone, payload, booster extension. This is actually the engine tube. This tube will actually be put into this tube. The fins actually go through and bond directly to the tube. We have 3 centering rings that go on the tube to basically space it out. This is how the tube attaches to the inside of this tube. And then at the bottom, I purchased an aero pack. We've used these on other rockets. Basically this is an engine retention. It's glued on the end. Once it's on, this screws off like this. This is the load. This is a 2-grain load that goes in. You screw it on, and that's your nozzle for your engine. So technically it would be down here. So this engine that we have right now, this is a 2-grain. This is the actual propellant that we bought for our level 2 certification. So I'm only going a J. I don't want to push the rocket extreme on my L2 certification. Once we're comfortable with the rocket, we will then start using 6-grain casings, which will come all the way up to here. So that's the kind of grain casings we'll need to go roughly 9,000 feet and breaking Mach 1, getting upwards of 900 miles per hour. So your centering rings, your fins, these are your couplers that make the tubes together. The up here is a bulkhead. The bulkhead goes up here. I've actually changed out. They did come up with eye loops, but with this kind of force, we switched these out. I switched them out to a stainless steel, like U-bolt, with the epoxied in. The shock cords attach to the E-bays and the 2 separate. I'm probably going to step this up to a higher grade, stronger shock cord. The way all this works is there's a altimeter bay. That's what goes in here. The altimeter bay goes together like so. We put the wing nuts on like so. I won't spend a lot of time on this, but basically once I said we've switched out the I bolts to the U bolts, we'll basically bolt the altimeter board. So pretty small board here, 9-volt battery, wires. They come out both ends of the bulkhead. So this technically, once it's put together, seals the electronics so it's not exposed to the gases. So you basically put it together like this. You put it in here. Put the other end on here, like so. Have to make some adjustments on it because it's sticking out right now. But basically these go together where it's completely sealed up. So these would be sealed. This guy goes on top like that to completely close it up. So basically all the electronics are inside and they're safe. This goes in the center here like this. So initially this is just held together with a push fit. When this injector charge comes off, this comes off. Parachute is mounted to here. The shock, the injector charges are here. Blows that out. Drogue comes out. We have actual what we call shear pins up here that will be pressed in. They're basically nylon screws. I had them here somewhere. But there was some nylon screws. Here they are. We push 4 of those in. We put a brass plate in here. So when the charge goes off, this keeps the nose cone from coming off when this charge fires. When we get within 500 feet, the charge on this end will fire. It will basically blow the nose cone off, and it's enough force to shear the pins. So it'll cut the pins, and this nose cone will have the chute attached to it. This is all the connections. These are the I bolts that were used. I replaced those with the U bolts. Some other things I do. This, by the way, this is a picture of the eBay electronics bay. You can kind of see.
Back. Oh wait, no, it's not there.
There you go. That just shows what it looks like when it's assembled. Some added things we add to it is on the shock cords we put this Nomex protector on the shock cord closest to the ejectors. So it's a fireproof material, keeps the charge from burning through the shock cord. So I've got 2 of those. And then on top of that we wrap the parachutes in this 12x12 parachute protector. So you wrap them up like a burrito, stuff them in. That way when the charge goes off, again, this is fireproof. It won't burn. The parachutes, we've had a lot of luck with those. Get a lot of use. Parachutes come up. So that's the raw pieces. The rocket's going to start looking a lot different. First things we'll be doing is doing the fiberglass. We're going to fiberglass again the engine tube and all the exterior tubes. So it'll look a lot different even in its raw form. So today's September 1st. We need any luck, we'll have this built and have our first launch before Christmas, weather permitting and time permitting. So stay tuned for more updates.